So figure out how many lines of symmetry each of these 6 shapes have. Assume they are regular. Alright, Madison, letter A. How many lines of symmetry do you have? What'd you say? 1. Very good. So smiley face can only be divided down the middle. If you try to do it horizontally, the face goes over the eyes, and that's not going to be symmetrical. Michaela, how many for letter B? 6. So each vertex to the opposite side. 1, 2, 3, 4. We have 6 here, 1 here. Letter C, Phoebe. Infinitely many. Okay, so your circle is always going to have infinite lines of symmetry. Sochi, letter D.
I only got 2.
2. Okay, so your rectangle is always just going to have 2. Letter D, Akansh. 4. So you have your vertical, your horizontal, and then both of your diagonals. And Takaya, how many for letter E? None. Okay, so for symmetry, okay, on your CBA, it's not a huge teak, but there will be a question or two about it, and it'll be something along the lines of how many lines of symmetry does blah 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 shape have, or draw the lines of symmetry that blah 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 has. Okay, these lines of symmetry are what we call reflectional symmetry. Okay, so you need to know that vocab word, reflectional symmetry. Okay, so it'll say how many lines of reflectional symmetry, which means you're splitting in half like a mirror image on the left side and the right side. Okay, how many lines of reflectional symmetry would a pentagon have, a octagon, a heptagon, etc.? Okay, but this is all you need to know about symmetry. Any questions before we move on to the transformations part? Okay. Alright, translations. What is another term that we could say for a translation? A slide, very good. So translation is the same thing as slide. Okay, and the way I remember it is because there's an SL in the middle of translation, and SL stands for slide. When you slide a image or translate an image, do you maintain congruency? Yes. Who remembers the one transformation that does not maintain congruency? Dilations, very good. Okay, translations. Example 1, translate the figure left 6 and up 8, give the coordinates of the new point. So take a minute and take every single point and go left 6 and up 8 and draw your new image and label your points. Albina, what do you get for A prime?
-4, 5.
-4, 5. Do we agree? Yes. Noah, what do you get for B prime?
-4, 0.
-4, 0. Do we agree? Sweet. C prime, Matthew, what do you get? 2, 0. Do we agree? Awesome. Carissa, what do you get for D prime? 2, 5. Do we agree? Awesome. Chloe, what do you get for E prime? -1, 3. Do we agree with her? Awesome. So as you can see, we just translated our figure left 6 and up 8. Okay, some vocab. What do we call the original image that we start with? What do you call the picture that you start with? I heard it somewhere. Pre-image. Okay, so your pre-image is there. Okay, and what do we call our figure after we have translated it? So after you've performed your, or applied your transformation, what do you call that? You start with your pre-image, and you end with your image. Okay, so your finished product after the transformation is what we call the image. So you have your pre-image and your image. Remember that when you are applying a transformation of any kind, your new points need to be labeled with the tick marks. Okay, so A prime, B prime, C prime, etc. Okay, a lot of us lose points here and there on our quizzes and tests because we don't properly notate our figures. So make sure you have your little tick marks after you apply your images, or apply your transformations, sorry. Okay, one last thing I want to introduce is what we call coordinate notation. Okay, your coordinate notation is a general rule, okay, and it's basically putting the words into notation. So it always starts with XY, yield. That's how you always start. If I'm moving left 6, am I affecting my X values or my right value, or my Y values, sorry. My X values, am I affecting them in a positive way or a negative way? So how would I write left 6? X minus 6. Okay? Moving up 8. Is that affecting my X's or Y's? Y's. And positive or negative? Positive. So how would I write that? Y plus 8. So my coordinate notation for this translation is x minus 6, y plus 8. So all of your x values of your pre-image, you're taking 6 away or subtracting 6. And all of your y values of your pre-image, you're adding 8. Okay? Left and down are negative. Right and up are positive. Okay? Left and down are negative. Right and up are positive. Make sure you pay attention and don't accidentally switch them and say x plus 8 and y minus 6. Okay? All of your movements left and right affect your x values. All of your movements up and down affect your y values. Okay, we're going to practice in example 2. It says describe each translation. Okay, so we're going to write it in words and in coordinate notation. So the first one is shape A to B. So I'm going to pick one of my corners. Okay, so I'm going to do the top left in each of them. And I'm going to figure out what translation has been applied. So how did I get from A to B? Well, I know I went down 3, 4, down 5, and then to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went down 5 and right 10. What would be my coordinate notation for this, TJ? How would I write number 1 in coordinate notation?
Which one?
Number 1. A to B. How do I write that in coordinate notation? Okay, remember coordinate notation looks like this. How am I going to write this in coordinate notation? Garrett, help him out. X plus 10, y minus 5. Okay, do 2 and 3 on your own. So you're going number 2, B to D, number 3, D to C. Write it in words and in coordinate notation. Blake, what'd you get for number 2? Words first.
So right 2 down 3. And then
Right to down more than 3.
did I count wrong? Oh, my bad. I didn't match them up. Okay, so 6.
Right to down 6, do we agree? Okay, so Blake, what would be the coordinate notation?
So x plus 2 and then y minus 6.
Very good. X plus 2, y minus 6. Phoebe, what'd you get for number 3? Words first.
Left 12, down 1.
Left 12 and down 1. What would the coordinate notation be?
X minus 12, y minus 1.
XY yields x minus 12, y minus 1. Do we agree? Okay, any questions over coordinate notation or how to visualize how a translation has been applied? Pretty simple, right? Okay. Like I said, the biggest thing here is making sure you don't accidentally switch your x and your y. So make sure left and right go on your x value, up and down go on your y value. Alright, example 3. Three-dimensional figures can be made using translations. So the first thing I want you to do is to plot those 4 points. So A is at -2, -2. Make sure you label them. B is at -2, 1. C is at 1, 1. D is at 1, -2. What shape do we have? A square. Alright, it says translate the figure 2 units right and 1 unit up. What am I going to pick on? Takaya, what would be the coordinate notation for 2 units right and 1 unit up?
For A, it would be...
Just the coordinate notation for 2 units right, 1 unit up.
Oh, X, Y, yields, X plus 2, Y plus 1.
Very good. X plus 2, Y plus, X plus 2, Y plus 1. Okay, I want you to translate it now. So translate your figure. Make sure you label your new points. Okay, step 3 says draw segments A prime, B prime, C prime, and D prime. So connect your line. Okay, what type of figure have we made? A cube. Okay, we have made a cube. What's another name for a cube? Rectangular prism. Very good. So a cube is what we're assuming, just because we don't know the lengths of these little pieces that we made. However, it's definitely a rectangular prism. Any questions on translations before we move on to reflections? Alright, those are the easy ones. Reflections. I want you to get out a highlighter or a marker, whatever you have. Okay, reflections. Okay, for the purpose of your CBA, you need to focus on mastering reflections over your X and Y axis. However, because this is pre-AP and we want to differentiate from on level, we are also going to look at reflecting over lines. However, again, for your CBA, focus on reflections over the X and the Y axis. So examples like 1 and 2. Okay. So example 3 is just a differentiation between on level and pre-AP. Example 1, reflect the points A, B, and C across the x-axis and name the coordinates. Okay, so first thing always is to highlight what you are doing. Okay, you're reflecting over the x-axis. Okay, after you've highlighted it in the problem, I want you to go and highlight the actual axis. Okay. We still make tons of mistakes, like when we were rotating figures around our axis, of rotating around the wrong one. So hopefully, if we can get into the habit of highlighting which axis we're reflecting over, We will limit those mistakes. If I'm reflecting point over the x-axis, is my x values changing or my y values? Your y values. So it's always the opposite. When you reflect over the x, your y values change. When you reflect over the y, your x values are changing. Okay, so we want to make a mirror image. So currently A is at what point? Negative 3, 4. So if I reflect over the x-axis, okay, I'm changing my y value to what? Negative 4. So where is A prime at? Negative 3, negative 4. Very good. Okay, B is currently where? 4, 2. So B prime will be where? 4, negative 2. Okay, C is where? Negative 1, negative 4. So where is C prime going to go? Where is C prime going? Negative 1, 4. Alright, looking at our pre-image and our image coordinates, it wants to know if we see a pattern. Did my x values change? No, we talked about that. Our x values weren't going to change, but our y values were. What happened to our y values? Not just from negative to positive, but what? Somebody said it at the back table before. It is always equal length from the x-axis, but what happened to our numbers and our signs? So how do I go from 4 to negative 4? You took the opposite, right? How do I go from 2 to negative 2? Opposite. How do I go from negative 4 to 4? Opposite. So you're just taking the opposite sign. So it's not always just positive to negative or negative to positive. It's always the opposite. Okay, so how would you notate the opposite? So if I'm going to make coordinate notation, x, y yields, okay, did my x values change? No, so those stay the same. How do I notate opposite y? Not plus or minus. Negative y. So anytime you have a negative, okay, so a negative 4 is going to be negative 4. A negative 2 is going to give you negative 2. A negative 4 is going to give you a positive. So when you take the opposite, okay, you're going to get the opposite sign. So if I were you, I would get into the habit of reading that x, y yields x opposite y rather than negative y, because it might confuse you and trick you into putting all of your signs as negative. So read it as x opposite y instead of x negative y. Any questions with reflecting over the x-axis? Okay, then on your own, I want you to try example 2. This time you are reflecting over the y-axis. So make sure you're highlighting your axis. Okay, so reflect over the y-axis and write your coordinate notation. Don't forget to write your rule. Practice using that coordinate notation. Alright, Naomi, what did you get for x prime? 2, 3. Balbino, what did you get for y prime?
Negative 6, 2.
-6, 2, very good. Chloe, what did you get for z prime?
Negative 2,
-2,
negative 5.
-5. And Macy, what did you get for your coordinate notation? Very good. X, Y yields opposite X, Y. So our Y values didn't change, but our X values took the opposite sign. Okay, so our Y values didn't change, our X values took the opposite sign. Okay, so it's really important that you guys start familiarizing yourself with coordinate notation, because on a CBA, you're not always going to be given the coordinate grid to graph. Okay, you may just be given these points and then asked what type of transformation was applied, and then your multiple choice answers will be just a bunch of coordinate notation. Okay, so you'll actually have to be able to know how to identify what transformation is made using coordinate notation. So you would have to know what's happening with these different coordinate notations. Alright, example 3. Reflect RST across the line y equals x and name the coordinates. Okay, so the first thing I want to actually do is write our coordinate notation. So we're always going to start with x, y yield. Okay, if I were to read this equation, what does y equal? X. So I know I need to put x in place of y. What does x equal? Y. So in this case, all we have to do is switch our coordinates. Okay, so if I were to read this, y equals x and x equals y. So y equals x and x equals y. So what would be r prime, Blake? Okay, if all you have to do is switch your coordinates, what would be r prime? Very good. 6, -4. Amen, what would be s prime?
2, -1.
2, -1. Blake, r, what would be t prime? -1, -6. And if we were to plot those points, 2, -1 is s prime. R prime is 6, -4. And t prime is at -1, -6. Oops. This one. Okay, so it should be a reflection over that line. Okay, what if my equation was y equals -x? What would my rule be? What does y equal? -x. I'm for sure putting -x in there. How am I going to solve for what x equals? So right now I have y equals -x, but if I want to solve just for x, what do I have to do? Divide by -1. So what does x equal? -y. So for reflecting over the line y equals -x, you have xy yields -y, -x, or opposite y, opposite x. Okay, so always just take your equation and solve for each variable. And remember that if it's a negative, you're not done solving. You have got to make sure that it's by itself completely. So you have a couple examples like that on your quiz, or on your homework. Alright, any questions over examples 1 through 3? So far, so good? Alright, on the back, I want you guys to do these by yourself. All you're doing is doing double reflections. So 4 and 5, you're looking at double reflections over parallel lines. 6 and 7, you're looking at a double reflection over intersecting or perpendicular lines. So basically, after you draw your images, okay, it wants to know how you get from the shape it provided you to the last image you draw. Okay, so what kind of transformation led you from the shape it provided you to the last one you draw? Okay, so do 4 through 7 on your own. You are doing double reflection. Alright, Alex, what happened in number 4? What transformation? So it's reflected over K and M, and you're looking at the image that they gave you and your current image. Translation, very good. Naomi, number 5, what'd you get? So if you get rid of the one in the middle, how do you get from the left to the right? A translation. Okay, Ronnie, number 6. How do you get from the pre-image to your last image?
A translation and reflection.
Not a translation and a reflection.
Just a translation.
Not a translation because it didn't maintain the same orientation. So this is just if this were to slide around, I want it to look like upside down.
Then just a reflection.
So that's not anything we've done today, but where are we leading into? A rotation. Very good. So it's kind of a trick question. So this is our stopping point of our notes. And number 7, Garrett. Okay, so you did reflect it, but in the end, we're looking for just one transformation. How did we get from here to here? And it's just a rotation. Okay, so that is where our stopping point is. Okay, on Thursday, we look at rotations. Rotations have 4 distinct rules that you're going to have to memorize. Okay, and then we'll look at composite transformation. So taking a figure and reflecting it, then rotating it, translating it, then reflecting it, kind of like a 2-for-1 type thing. Okay, so familiarize yourself with the translations and the reflections. Those are the easier ones of the 3. And then Thursday we will do rotations. Let's see, you have 30 minutes before we're going to do the skills check.